Yesterday we discussed some applications on the motion in the gravity. No?
Yes, sir.
How many
Under
applications?
gravity.
Uh, how many applications under gravity? 2 or 3?
3, sir.
2 completed.
Yes,
Right.
sir.
Now
Yes,
it
sir.
is third. Now it is third one. That is a body dropped freely. A body dropped freely from a multi-storied building. Multi-storied building can reach the ground in T1 seconds. It is stopped in its path. It is stopped in its path. After T2 second. After T2 second. And again dropped freely. And again dropped freely from the point. From the point. The further time taken by it to reach the ground is T3. Find T3. Fine.
Okay, sir.
Okay.
Okay, fine. Now you can see a body is dropped freely. Means what?
Initial velocity is 0.
Initial velocity is 0. Okay, here initial velocity is 0. This is point A, this is point B. It reaches the ground in a time of T1 seconds. Okay, na? Let us consider this is at a height h1. This is at a height h1. Now, the same particle, okay, it is stopped for a time of T2 seconds. Okay. This is point C, this is point E. It is having a height h2. From D to ground, this one. This point is E. Okay. Where B and E are lying on the ground only. Okay. This height is h3. Takes a time T3. Takes a time T3. Okay. Fine. I need
sir.
to find T3. In both the cases, it is dropped freely.
Yes.
So from diagram,
Sir.
can I say h1 equal to h2 plus h3?
Yes, sir.
H1 equal to h2 plus h3. Since by using the principle, which formula? S equal to ut plus half at
Half.
is. That means h1 equal to half g t1 square. Similarly,
sir.
h2 and h3, since h1 equal to h2 plus h3, half g t1 square equal to half g t2 square. And then one is the question at this point D, and again dropped freely. That means here the initial velocity will be 0. Right?
Yes, sir. Yes, sir.
So that's why I'm writing as half g t3 square. Otherwise, whenever it is dropped freely, at t will have the velocity. Right?
Yes, sir.
At t will have velocity. Since they gave that it is again dropped freely, so t1 square equal to t2 square plus t3 square. That means t3 square equal to t1 square minus t2 square. Okay, na?
Okay, sir.
Okay,
So
sir.
t3 equal to under root t1 square minus t2 square. Okay, na?
Okay, sir.
That is the third application. These are the applications on the particle is projected vertically downwards. Particle is projected vertically downwards.
Free
Now,
fall.
now applications of object or particle is projected vertically upwards. Vertically upwards. Okay. Fine. Whenever the particle is projected of vertical upwards, what are the conditions? What are the conditions?
U is not equal to 0.
U not equal to 0.
V equals to 0.
V
V
equals to
equal
0.
to 0 at
Acceleration
maximum height. Acceleration
minus G.
equal to minus G. Right? These 3 points,
Yes, sir.
remember. Fine.
Okay.
Okay, fine. First application. Write down. If velocity of a body, if velocity of a body in nth second, is V, then in n minus 1th second is, then in n minus 1th second is V plus G. Okay. Find the velocity in n plus 1th second while ascending or moving up. While it is ascending, we need to find velocity of the particle. Okay, na? Fine. Na?
Okay,
Okay,
sir.
sir.
Okay. That means we are having that. Let us consider this is my ground. Okay. Particle is projected up. Okay. It takes a time n seconds. rises to a height h. It is not the maximum height. Okay. Distance traveled in nth second. It is, I know that u plus a by 2 into 2n minus 1. In nth second, they gave it as v. Okay. Since it is projected up, that is ascending, a equal to minus g. Okay, na?
Okay, sir.
Fine. Malta's equation 1. Now, we are considering, suppose this is A, this is B, and it is C. This is nth second now. B to B, nth second. A to B, it is n minus 1 second. Okay, na?
Okay, sir.
Okay, fine. Suppose Sn dash equal to u minus g by 2. Instead of n, I'll substitute n minus 1. So, Sn dash equal to u minus g by 2 into 2n minus 3. Okay, fine. This one
Okay, sir.
I am writing as 2n minus 1 minus 2.
Yes, sir.
Separate it. G by 2 into 2n minus 1 plus g by 2 into 2. U minus g by 2 2n minus 1 means v plus
Yes, sir.
c. That's what they gave now. N minus 1 second. Similarly, Sn double dash equal to u minus g by 2 into, instead of n, I'll keep n plus 1. Because we need to find velocity in the n plus 1th second. See. Okay, na?
Okay, sir.
Fine. So that is u minus g by 2 into 2n plus 2 minus 1, 2n plus 1. Okay. So this I am writing as u minus g by 2 into 2n we need to get minus 1 we need to get. Okay.
Okay, sir.
Sn double dash equal to u minus g by 2 into, we are having 2n plus 1. Na?
Yes, sir.
Right? 2n
2n
plus
plus
1.
1.
Okay. We need to get minus 1. Okay. So u minus g by 2, 2n, in order to get minus 1, what we'll do is 2n plus 1 minus 2 plus 2. I will add 2 so that these first three terms, which we can write it as u minus g by 2 into 2n minus 1 plus 2. Okay, na?
Okay, sir.
Is it fine? Cherry. Okay, na?
Yes, sir. Okay, sir.
Okay, fine. So u minus g by 2 into 2n minus 1 means I can write as v, first equation.
Yes, sir.
Okay. So Sn double dash equal to v minus g.
Yes, sir.
Okay. Fine.
Yes, sir.
Okay. This page completed.
No, sir. 1 minute.
Huh?
Diagram. Completed, sir.
Completed, Cherry completed,
Yes, sir.
completed.
చెత్త పడేసేది చెత్త ఇది.
Okay, na? Completed,
Yes, sir.
Yes, sir. Completed.
okay, na? Completed.
Yes, sir.
Completed.
Okay, fine.
Completed, sir.
Completed.
Completed, sir.
Okay, fine. Next, I think let's see. First application. Next, second application in this vertical upwards. Okay. Now we derive the equations of motion by neglecting air resistance. Right? By neglecting air resistance, we got the equation of motion as V equal to U plus AT
Yes, sir.
and x equal to ut plus half at square.
Yes, sir.
And then v square minus u square equal to x. Now suppose if we are having air resistance, okay, that is a body is projected vertically up with a velocity u. With a velocity u from ground. in the presence of constant air resistance, constant air resistance, that is capital R. Okay, na?
Okay, sir.
That means sometimes what will happen, due to air, object will fall down or object will move up. Okay, na? Fine. If it reaches the ground, with a velocity v, then okay,
Okay, sir.
fine.
Fine, sir.
Number, suppose A, it is height of ascent equal to height of descent. Height of ascent. That means how much it will raise. Okay, how much it will raise. That is equal to, with the same height, it will descend. Height will be the same. Okay, na?
Okay, sir.
Yes, sir.
Fine. Na?
Yes, sir.
Fine. Fine. Now, time means what I can say, distance by speed. Okay.
Okay, sir.
Yes, sir.
Whenever it is coming down, we are having the gravity, mg will act. Air resistance will act upwards. Okay. So, since it
Okay.
is falling down with an acceleration A, we can write as ma equal to mg minus r. So, acceleration equal to mg minus r by m. Okay, na? Fine. Na?
Okay, sir.
Okay, fine. This time I can also write it as v by a. That is acceleration equal to velocity by time. Okay,
Yes, sir.
fine. Na?
Okay,
Okay.
sir.
So, time of descent, TD. That is velocity by acceleration. That means whenever it reaches ground, they give velocity v na. V by acceleration. That is mg minus r by m. Okay, na? That is nothing but mv by mg minus r. Is it fine?
Yes, sir.
Okay. See, how I wrote mg minus r means, since it is accelerating down, downward force is more than the upward force. And these two are forces, mg and r, air resistance. So we can say that it is both are opposite direction, net force will be in opposite direction. If forces are same direction, then we will add. Okay, na? Okay. Time of ascent. Gravity is acting downwards and air resistance is also acting downwards. So ma equal to mg plus r.
Yes, sir.
ma equal to mg plus r. So time of ascent equal to moving with a velocity u by mg plus r by m. That is mu by mg plus r. Okay, fine.
Okay, sir.
Then, fine. Correspondingly, ratio of velocities v by u. Okay, v by u. That is, since v square minus u square equal to 2as, so v square is directly proportional to a. So v by u equal to under root mg minus r by mg plus r. Okay, na?
Okay, sir.
Okay, sir.
Fine. Na?
Okay, sir.
Fine. Next is second application. Na? Next third application. Third application, it is that a body projected vertically up, a body projected vertically up, crosses a point, P at a height h, above the ground, above the ground at time t1 seconds, at time t1 seconds. Okay, and at a time and at a time t2 seconds, reaches the same point, while coming down. Okay, as shown in diagram. Let us consider this is the ground. This is point P. Okay. And it is at a height h, taken at time t1 seconds. Fine. Na?
Yes, sir.
Now, the same particle reaches the same point in a time taken t2 seconds. Okay. Na? Here it is projected with an initial velocity u. Fine. Na? Okay. This page completed.
No, sir. 1 minute.
Right.
Completed, sir.
గ్రీన్ కలర్ ఉంటుంది నాకు చెప్తే
Yes,
నేను చెప్పుకున్నాను
sir.
కదా ఏం చెప్పాలి ఇది ఇది పెనాయిల్ కదా ఇది ఇది పెనాయిల్ వాసన వస్తుంది మరి గ్రీన్ కలర్ ఉంటుంది ఒక సబ్బు లాగా
Completed, sir.
Completed.
Yes, sir.
Completed, sir. Completed, sir.
Take it up. Get it completed.
Yes, sir. Completed.
Now see, body is projected vertical up to a point P at a height h above the ground. That means projected with an initial velocity u. Right? So we can write by using the principle s equal to ut plus half at square. That means h equal to ut minus ut1 minus half g t1 square. Can I say?
Yes, sir.
Okay, fine. So multiply by 2 on both sides. That is g t1 square minus 2 ut1 plus 2h equal to 0.
Yes, sir.
Okay, now fine. It is a quadratic equation. Okay, it is in the form of ax square plus bx plus c equal to 0.
Yes,
Yes,
sir.
sir. Yes, sir.
Instead of x, we are having t1. I'll
Yes, sir.
find the roots. That is by using the formula minus b plus or minus under root b square minus 4ac by 2a.
Do
So t1 equal to minus b and minus 2u plus or minus under root, that is 4u square minus 4 into a means c, c means 2h by 2g. Okay. T1 equal to so take 2 common, that is 2u plus or minus. Here under root 4 I will take common, which will come to outside as 2. U square plus, sorry, u square minus 2gh by 2g. So T1 equal to u plus or minus under root u square minus 2gh by g.
Yes, sir.
So that means it will have the two values. Okay, two roots, na? Two values.
Hmm.
T2 equal to u plus under root u square minus 2gh by g, and another one it is u minus under root u square minus 2gh by g. I consider instead of T2, I consider as T0. Two roots, T0 and T3. Okay,
Okay, sir.
fine. Okay. So T0 plus T3, can I write as 2u by g? Or not?
Yes, sir.
Initial velocity of projection it is v into T0 plus T3 by 2. Okay,
Okay, sir.
now
Sir, 1
product,
minute, sir. I'll write.
I'll give the
Okay.
product of the roots. T0 T3, that is u plus under root u square minus 2gh by g multiplied by u minus under root u square minus 2gh by g. So T0 T3 equal to 1 by g square times. Numerator, it is in the form of a plus b into a minus b. Right? A plus b into a minus b means a square minus b square. Okay.
Yes, sir.
That is, we'll get as 2gh by g square. Nothing but 2h by g. Okay. Fine. Okay. T1. Okay. Initially, we got as T1. T1 is nothing but T0 plus T3. Two roots now. So, h equal to half g T0 T3. From this equation, T0 T3 equal to 2h by T0. Cross multiply.
Yes, sir.
Right. We got it. Now,
Yes, sir.
we need to find maximum height reached above the ground. Above the ground. Okay. Fine. That is H
Okay,
max.
sir.
H max. Okay. Since we know that ut plus half dt. Okay. Initial velocity, where we got it as v into t naught plus t into t naught plus t3 by 2 into time. Okay. That is t naught plus t plus g by 2 into t naught plus t3 whole square. Okay. Fine.
Okay, sir.
Okay, sir.
This is the total time now. Upon solving, we'll get as v by 8 into t naught plus t3 whole square.
Yes, sir. Yes, sir.
There, this page completed. Huh?
Yes, sir.
Right. Of this.
Completed, sir.
Carry over.
Yes, sir. Over, sir. Done, sir.
Completed, sir.
Up to here it is applications of the motion and gravity when it is projected vertical upwards. Okay. Fine.
Yes, sir.
Okay, fine. Next step. It is graphs of displacement versus time and velocity versus time. Okay. Enter the graphs. I will divide as first in uniform motion and in non-uniform motion. In uniform motion, we know that speed is constant. Speed is constant,
Yes, sir.
and then as speed is constant, velocity will be zero.
Yes, sir.
Yes, sir.
Okay. Fine. Okay, fine. So speed equal to constant and acceleration is equal to zero, such that displacement is proportional to time. S is proportional to t. So first graph on x-axis it is time and on y-axis it is displacement. S. So from here, can I say that S equal to Ct? C is speed. C is the speed. Okay. Okay, fine. Now you can see instead of y-axis, we are having the uh, displacement S. Okay, na?
Okay, sir.
Instead of x-axis, we are having the time. It is in the form of y equal to mx, right? Now,
Yes, sir.
when t equal to 0, what is the value of s? When t equal to 0, what is the value of s?
Infinity.
Oi, s
Non-zero.
equal to ct,
Oh,
t equal to
zero.
0,
Zero, zero.
s equal to 0. That means lying
Yes.
here. As t increases, s also increases.
Yes, sir.
When
Yes, sir.
t equal to 1, s equal to c.
Yes, sir.
When t equal to 2, s equal to 2c.
Yes, sir.
So it forms a straight line. That is the shape of y equal to mx. Now.
Yes, sir.
That is
Yes,
path.
sir.
It is straight line passing through origin, with positive slope. With positive slope. Okay, na? Fine.
Okay, sir.
That is the shape of the ST graph. Next, VT graph. On x-axis it is time, and on y-axis it is velocity. In uniform motion, distance equal to displacement.
Yes, sir.
So as distance equal to displacement, can I say that speed equal to velocity?
Yes, sir.
Yes, sir.
Speed equal to velocity. So that is velocity is constant. Na? Oh, no. See here.
Yes, sir.
Whatever be the time, velocity is constant. Okay. That is
Yes, sir.
parallel to the time axis. Parallel to time axis. Okay, na?
Okay, sir.
Fine. So slope under VT graph gives displacement. Can I say? Sorry. Acceleration. Okay, na?
Yes, sir. Okay, sir.
What is the formula for slope?
Root of
Slope formula.
M1.
If we have 2 points, x1 comma y1 and x2 comma y2, what is the
Root
slope
X2.
formula?
X1
Root
minus
X2.
X2 plus Y1 minus
Very
Y.
good, ma. Super, ma. y2 minus y1 by x2 minus x1. Whatever you told, that is for distance between the points. Okay,
Okay.
Okay, sir.
fine. Na?
Yes, sir.
Hmm. So slope under VT graph means V2 minus V1 by T2 minus T1.
Yes, sir.
Next, area under VT graph. Area under VT graph gives displacement. Okay, na?
Okay, sir.
Fine. Next, here it is. Third point it is area under ST graph. Sorry, not area. Slope under ST graph. Slope under ST graph gives, okay, displacement by time means what?
Velocity.
Velocity. Okay, na? These 3 points
Okay, sir.
remember, most important, which again will use in the numericals. Okay, na?
Okay.
Right on. Right on.
Yes. Yes, sir.
Hello. Hello. సార్ చెప్పండి. హైదరాబాద్ సార్. నేను కనుక్కుంటాను. నేను కాల్ చేస్తాను. ఓకేనా?
Okay, sir.
Okay, sir. Completed, sir.
That's what in uniform motion. See, now we are having the non-uniform motion. In non-uniform motion, okay, number one, case one it is moving with an acceleration A and initial velocity U. Okay, moving with an acceleration A and initial velocity at U. Fine. Fine. Suppose, firstly, we know that S equal to ut plus half at square. Okay, now ut, that is nothing but distance or displacement.
Yes, sir.
Yes, sir.
Okay, fine. When t equal to 0, what is the value of s?
0.
Oi. When t equal to 0, s equal to s naught.
Okay, sir.
Okay, that means when t equal to 0, 0 comma s naught, this coordinate lies on where here. Okay.
Okay, sir.
Thereafter, when t equal to 1, that means when t equal to 1, s equal to s naught plus a by 2. When t equal to 2, s equal to s naught plus 4a by 2. That means from here, it follows the shape parabola. Okay,
Okay, sir.
follows the shape parabola. Next, VT graph in the same case. Okay, moving with an acceleration a and initial velocity as u. That is, since we know that v equal to u plus at, that is at time t equal to 0. At time t equal to 0, what is the value of v?
Yeah.
So, v equal to u plus at.
Yes, sir.
When t equal to 0, what is the
U.
value of v?
U.
U. So, coordinates will be 0 comma u.
Okay.
Okay. Thereafter, velocity is directly proportional to time.
Yes, sir.
So, from here it is linear shape, straight line.
Yes, sir.
Okay, na?
Okay, sir.
That is case 1. Now, case 2. Moving with an acceleration a, moving with an acceleration a and starts from rest. Starts from rest. Then what is the initial velocity? What is the initial velocity?
0.
0. Okay, na?
Okay, sir.
Fine. Na? Okay.
Yes,
In
sir.
this case, in this case, we need to find the um, ST graph and VT graph. ST graph. Okay. Since S equal to ut plus half at square, initial velocity is 0. So S equal to half at square. Okay, na?
Okay, sir.
When t equal to 0, what is the value of S?
0.
Okay, na? Seri, okay, na? Is it right?
Okay, sir.
When t equal to 0, S equal to 0. Here, S is proportional to t square.
Yes, sir.
That means, in the previous case, this variation of displacement starts from the fixed point, having an initial displacement. But here, initial displacement is 0.
Yes.
Okay, na?
Okay, sir.
Fine. Na?
Yes, sir.
Okay, fine. Now, VT graph. Here also initial velocity is 0. Since V equal to U plus AT, we'll have V equal to AT. V equal to AT. That means when T equal to 0, what is the velocity? When T equal to 0,
0.
V equal to 0, so that
Yes.
means at origin. Since here velocity is directly proportional to time,
Yes, sir.
that means what will be the shape of the graph?
Linear.
Straight line passing through origin.
Yes, sir.
Okay, na? Right.
Okay, sir.
Now, stage 3. Till now we discussed moving with an acceleration. Right. Now, case 3 it is moving with an retardation, having initial velocity u. Case 3. Moving with retardation or deceleration. Retardation means, what is retardation?
Negative acceleration.
Negative acceleration, having initial velocity u. Having initial velocity as u. Okay, na?
Okay, sir.
Right. So, since first it is ST graph. ST graph. Since S equal to ut plus half at square. Okay, na? But here we are having an retardation. But here we are having the retardation. That is negative acceleration. Okay, na?
Okay,
So,
sir.
so it is ut minus half at square.
Okay, sir.
Ut minus half at square. Okay, fine. So, same as like before, ut I'll consider as S naught.
Yes, sir.
Okay. This is the time. And here is when t equal to 0, what is the value of S naught?
That's not.
S naught. Okay, na? Fine.
Okay, sir.
That means we'll have the coordinate here. This value it is S naught. From here, as time increases, S value decreases.
Yes, sir.
S value decreases. So this is also parabolic shape. Like this. Okay, na?
Okay, sir.
Fine. Next, VT graph. Next it is VT graph. That is, since V equal to U plus AT, here
Yes,
it
sir.
is deceleration. Na?
Yes,
So
sir.
I'll write as U minus AT.
Okay, sir.
On x-axis it is time and on y-axis it is velocity. Okay. When time t equal to 0, we'll have initial velocity u
Yes, sir.
and then decreases. Okay. Na?
Okay, sir.
Okay.
Fine.
Fine, sir.
Okay, fine. Right. Next case, moving with retardation A and starts from rest. Right? Can you draw? Or you can see in your material.
Sir, can you repeat once again?
Next case, moving with retardation and starts from rest.
Yes, sir, we can draw.
Right?
Yes, sir.
Okay, fine. Okay. Uniform motion completed, na?
Yes, sir. Sir, 1 minute. Show the next. Yes.
This page completed.
Yes, sir.
Yes, sir.
This page
No, sir.
completed.
Yes, sir. Completed.
Yes, sir.
Completed.
Yes, sir. Done, sir. Completed, sir.
Completed, sir.
Completed.
Yes, sir.
Yes, sir. Completed. Completed, sir.
Up to here, remember,
Okay, sir. Okay,
these are the synopsis. Okay. Tomorrow onwards, we will start problems.
Okay, sir.
Okay. Na? On the,
Okay, sir.
Okay, sir.
with material ఇచ్చారా
ఇంకా తీసుకోలేదు సార్.
తీసుకోలేదు. ఎక్కడ ఉన్నావు నువ్వు?
ఇప్పుడు అదే బర్గర్ లోనే ఉన్నాను సార్.
ఎక్కడ ఉన్నావు? ఇంకా తీసుకోలేదా? సరే, నాన్న
తీసుకో.
చెప్తాను. సరే, నేను
ఓకే.
ఎప్పుడు మీకు రీఓపెనింగ్?
15th అనుకుంటాను సార్.
15th. ఓకే, ఫైన్. సరే సరే. ఓకే, ఫైన్. టుమారో విల్ మీట్.
ఓకే సార్.